Good evening, ma'am.
Good evening, Kirtna. Kirtna, have you done the revision of the last class?
Yes, ma'am.
Okay, so did you find any doubt?
No doubt, ma'am.
Okay, so okay, let's start the class. Yesterday we have discussed the last topic, that is homogeneous and heterogeneous equilibria, right?
Yes, ma'am.
Okay, let's see. Today we have to start with constant, that is my equilibrium constant, okay? Basically, the term that we are using, like Kc, right? We are representing Kc as a equilibrium constant, right?
Yes, ma'am.
So this equilibrium constant has some, has some characteristics. So this is my equilibrium constant. Kirtna, your video should be on. Kirtna,
Yes, ma'am.
video should be on, beta.
Yes, ma'am.
So this equilibrium constant has some characteristics. First is that it is applicable only at equilibrium state. Okay. Whenever we have the equilibrium state, then we say that there is a equilibrium constant. Okay.
Yes, ma'am.
Equilibrium constant has definite value for every chemical reaction at a particular temperature. Has definite value for every reaction, but at a particular temperature. If you change the temperature, then your equilibrium constant will also change.
Yes, ma'am.
Equilibrium constant never say depend on the initial concentration. Whatever we have the concentration, it is not dependent on that one. Only on the initial. But when the reaction got started, then it will depend on the concentration. Just it is. It is independent of initial concentration. Okay.
Yes, ma'am.
And yesterday we have discussed that it is independent of catalyst also, because catalyst doesn't alter the equilibrium.
Yes, ma'am.
This equilibrium constant has some units also, and it has different units for different reactions. It has different unit for different reaction. Okay.
Yes, ma'am.
If the number of moles of reactant and product are same, suppose 2 moles are reacting and 2 moles are forming in the product, then K has no unit, because delta N will be 0. as product will be equal to reactant,
Yes, ma'am.
right? Suppose say if you have a reaction, this one, you have this reaction and we have to write K equilibrium for this reaction. So what we will write? Concentration of C, concentration of D, concentration of A, and concentration of B, correct?
Yes, ma'am.
So for concentration, what we will write? Concentration is mole per liter, C plus D, and it is mole per liter, A plus B, correct?
Yes, ma'am.
So I can write that Kc unit will be equal to what? Mole per liter, C plus D minus A plus B. Can I write this thing?
Yes, ma'am.
Or I can say mole per liter, delta N,
Yes, ma'am.
correct? That's why I said that if my delta N will be equal to 0, this value will be equal to 1 and Kc will not have any value.
Yes, ma'am.
Clear? If I have to write it for the reaction, like I'm having liquid, then I will write Kc will have the value this one. But if I am having a reaction that is in gaseous phase, then my unit will be equal to bar to the power delta N.
Yes, ma'am.
Suppose say I am having this reaction, nitrogen gas combining with hydrogen gas, it will form ammonia gas. So in this reaction, I can see my delta N will be equal to what? What will be the delta N for this reaction?
0.
No. First you have to balance the reaction. है ना? कल पढ़ा था ना?
Yes, ma'am. -2.
Yeah. So in this case, my delta N will be equal to -2. So the unit for this reaction will be equal to bar to the power -2. Clear?
Yes, ma'am.
Now, next point is when you add multiple reactions. Like in electrochemistry, we have done that we have added the oxidation reaction, reduction reactions to get overall reactions. In the chemical kinetics, we add so many reactions. So when we add reactions, so that time we will multiply the equilibrium constant for these reactions. Suppose say, if I am having N2 plus O2 is in equilibrium with 2NO, 2NO plus O2 gives me 2NO2 and N2 plus 2O2 gives me 2NO2. Okay, this is my K1, this is my K2 and this is my K3. I know that when I add these two reactions, 2NO will get cancelled out with this one. So N2 plus 2O2 will gives me 2NO2.
Yes, ma'am.
So my K3 will be equal to K1 multiplied by K2. I have to multiply the equilibrium constant if I am adding the reactions.
Yes, ma'am.
Clear? Or you can simply check it from here also. Like if I write K1 will be equal to what? NO square N2 and O2. K2 will be equal to NO2 square NO square and O2. Correct?
Yes, ma'am.
And my K3 will be equal to what? NO2 square and 2 O2 square. Correct? So if I simply multiply K1 and K2, K1 multiplied by K2, what I will get? NO square and 2O2 getting multiplied by NO2 square, NO square and O2, correct? So if I solve it, NO square get cancelled by this one. And what I will get? I will get NO2 square divided by N2 and O2 square. And that will be equal to this one. So that's why I can write it like K3.
Yes, ma'am.
Clear?
Yes, ma'am.
So in this way, we simply multiply it. Now, if I am having a where we use the equilibrium constant, like what is the need of using the equilibrium constant? So we have an application for equilibrium constant also. So application for equilibrium constant. First application is to predict direction of reaction. We can predict that in which reaction my reaction will proceed, either in the forward direction or in the backward direction. When a question we have, we say that Q is there, we call it as reaction quotient. That we also determine with the help of a particular reaction. Okay. So what we do further, like equilibrium constant for a particular reaction will be given to you. And it has been asked that what you have to find out that whether your reaction will proceed in the forward direction or in the backward direction. So suppose you are having this reaction. Concentration will be different than that of equilibrium. This is the general concentration. And in equilibrium, like for Q, what we will do, we will use the same formula that we are using for equilibrium. The formula that same one we are using to find the equilibrium constant.
Yes, ma'am.
But in the equilibrium constant formula, we put the concentration over here that is present at the time of equilibrium. But in Q time, we put that concentration that is present at the particular time basically. When we have to decide that now our reaction will move to the forward direction or backward direction. But it has not achieved equilibrium. Clear?
Yes, ma'am.
So we can find out Q. Now you have both K and Q, right? So if your Q is greater than K, then your reaction will proceed in reverse direction or in backward direction. Means reaction कैसे होगा अब backward direction में होने लग जाएगा. When your K is greater than Q, then your reaction will proceed in forward direction. ऐसे direction में जाएगा. And when your QC is equal to KC, it means your reaction is in equilibrium. It will not shift to any position.
Yes, ma'am.
Clear? Just go through this, then I'm giving you a question to solve. Just go through this one. So you will be able to solve the question. Okay?
Okay, ma'am. Ma'am, can you scroll up? Ma'am, can you scroll it? 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 Done, ma'am.
Okay, now I am giving you a question. Okay, the concept is clear now.
Yes, ma'am.
The value of Kc for reaction 2A plus gives B plus C is 2 into 10 to the power minus 3 at a given time. Composition of reaction mixture in which direction reaction will proceed. Question is clear, Kirtna?
Yes, ma'am.
Just try to do it.
Ma'am, is it backward reaction?
How did you done that question? Your answer is correct. How did you solve?
QC is the product of the product divided by the
QC
square
is
of the.
this one you have taken.
Yes, ma'am.
So it will be equal to 1, right?
Yes, ma'am.
Okay. Now now your QC is greater than KC. So your reaction will be backward. Correct. The next application is we can calculate equilibrium concentration of reactants or products. How we calculate the equilibrium concentration? The first step that we have to do is you have to balance the reaction. Okay.
Yes.
Suppose say a reaction is given to you that A plus B is giving you C. This is a balanced reaction, suppose say. I can say that at time 0, my A is X and B is X because 1 moles are there.
Yes, ma'am.
And when it attains the equilibrium, I can say that at time T, A is reacting 1 mole, then B also reacts 1 mole.
Yes.
So 1 mole of C will be formed because 1 mole of A reacts with B. Or suppose I say that concentration of A is X and concentration of B is Y. So if 1 mole of A is reacting with 1 mole of B, it means X minus 1 will be Y minus 1 and it will form 1 mole of C.
Yes, ma'am.
I have the equilibrium constant for the reaction. So I can write the concentration of C divided by concentration of A and B. Concentration of C is 1, A is X minus 1 and B is Y minus 1.
Yes, ma'am.
And some other data is also there, so we can easily find out the concentration of every element.
Yes, ma'am.
Okay, so based on this concept, a question is there, that is 13.8 gram of N2O4 was placed in 1 liter reaction vessel at 400 Kelvin and allowed to attain equilibrium and 2O4 gas is reacting with 2NO2. Total pressure at equilibrium was found to be 9.15 bar. Now calculate Kc, Kp and partial pressure at equilibrium. Okay. Just try to do, otherwise I will let you know. भाई को दिया, भाई कर देगा, भाई से करवा ले। Are you trying, Kirtana?
Yes, ma'am. Ma'am is KC 1.5.
First, you have to find Kp, Kirtna, because your reactant and product are in gaseous phase, na?
Yes.
And total pressure has been given to you. So you can find the Kp first. And after using the formula Kp is equal to KCRT delta N, then you will find Kc.
Okay, ma'am.
Done कितना?
No, ma'am.
Still doing?
Yes, ma'am.
Okay.
Ma'am, KP is 57.5 and KC is 190.9.
Just wait. KP is?
57.5.
No, it should be 85 point something. We will discuss it. Sure. Okay, I will tell you the solution of that one.
Okay, ma'am.
Okay. Done. Any other doubt?
No, ma'am.
Okay.